Hey there, hope you're having a wonderful day. In this video, we're going to go over inheritance in Python. So inheritance is a very important topic in object-oriented programming, and it refers to the relationship between different classes. And that relationship is in the form of a class hierarchy, or ranking. So when we talk about ranking, we have one class above another class. So inheritance allows us to create child classes that are built upon existing parent classes. So by building upon classes, a child class can inherit all attributes and methods from a parent class. So this is for promoting code reusability. This allows us to write the code once and reuse it multiple times. And the parent class is usually used as an interface for various child classes. So notice here I use the terminology child and parent. So we have a parent as the base class, and the child is a new class that inherits from the parent. And you'll find that in programming, we have a lot of synonyms for terminology. So you can have a parent class and child class, or it would be base and derived, or super class and subclass, or superclass. So super means above and sub or supra means below. Just like how a parent is above a child in a family tree, or you'll have a base class and anything that inherits from a base class is derived from the base class. Alright, so that's pretty much the terminology. Now let's go over an example. So in a previous video, I implemented these three character classes. They represent different character classes from video games. So I have a warrior, mage, and archer. And in each constructor, we have a health of 100 and a weapon, and each one also has a way of attacking. Now, what if I want to add more attributes? Let's say I want to add a level, because in video games we have levels. So I'll do level is 1. And let's say to level up, we need some experience. So I'll do self.experience is equal to, let's say, -100. So the reason why I use a negative number is because once we hit 0, we level up and then we set the experience back to negative again. And maybe to attack, we need some form of stats like power or strength. So if I do self.power is equal to 5. What about defense? Self.defense is equal to 5, and so on. So there's a lot of attributes that we can add to a warrior. And of course, we will need to add these attributes to our other classes. So you can see every time I need to add another attribute to a warrior, I need to copy and paste that to magician. And I would have to do the same for the archer class. And the same applies if I want to add another method. Let's say instead of attacking, I want to defend or block or recover my health points. I would have to copy and paste that method onto my other classes. So this is very error prone because maybe I might change the value to 10 by accident, or I might miss a value. And this is not maintainable when you have a lot of different characters. So instead of doing this, what we should do is create one base class or parent class and have the warrior, mage, and archer inherit from that class. So I'm going to get rid of this and this as well. So let's create a base class, and I'm going to call this game character. And the reason why I use the word game character is because if I just do character, that sounds like a literal character. And what does a game character have? Well, in our constructor, we can add a health and a weapon. In this case, our three different classes have different weapons, so I'm going to default this to none. And then we have an attack, so I'm going to add an attack method. And for now, I'll just do print attacked with a punch, because in our three different classes, we have different forms of attacking. Alright, so I have our base class or parent class, and I'm going to have each of my other classes inherit from this game character class. So I'm going to get rid of this code and put pass, and let's do the same over here and over here. Okay, so what we now need to do is have each class inherit from the game character. And to do so, in the class decoration, where we have our class name, we just add a parentheses and we type in the class that we want to inherit from. And I can do the same for mage and archer. Okay, so now each of these classes, warrior, mage, and archer, will inherit from game character. And so now I have some code where I create an instance of warrior, mage, and archer. And then I create a team, which is a list of warrior, mage, and archer. And then I iterate through each member of the team and call the attack method. Now you can see in our warrior, mage, and archer class, I did not define any attack method. I just have the keyword pass. However, in our game character class, we do have an attack method. So if I save and run the program, you can see each character attacked with a punch. And in our for loop, I can also print member.health and member.weapon. So now if I save and run the program, you can see each member has 100 health and no weapon. So each member has inherited the attributes health and weapon, and they also inherited the attack method. Now let's do some type checking. What is the type of each team member? So I'm going to comment this out for now, and I'm going to print type of member. So by using this type function, we can figure out what is the type of each object. So I'm going to save and run the program, and you can see we get warrior, mage, and archer. Now what happens if I do type of member is equal to warrior? So let's save and run the program, and we get true, false, false. And that is because the first member is a warrior, while the other two members are mage and archer. Okay, so now what happens if I do type member is equal to game character? Will I get true for all of them? Let's find out and run our program. So you can see we get false for each one. And that is because when you use the type function to check the type of an object, it does not consider the class hierarchy. It only considers the immediate type of the object. So a warrior should also be a game character because it inherits from a game character. So instead of using the type function for type checking, we can use another function. And that function is called isInstance. So here I can put member and a class name. So I'll do warrior as an example. So what we're checking here is if member is an instance of warrior. So instance is also another way of saying object. So let's save and run the program. And you can see we get true, false, false. This is expected because the first member is a warrior and the other two are mage and archer. Now if I change this to game character and I save and run the program, you can see we get true for all of them. So if a warrior inherits a game character and we create a warrior object, that object is both a warrior and a game character. And the same applies for mage and archer. So when you're doing type checking, it's usually better to use the isInstance function instead of using the type function. The type function is only useful for figuring out the immediate type of an object. Alright, so let's get rid of these two, and I'm going to uncomment these two out. So we have our three classes that inherit from this base game character class, and what we can do is add some extra attributes. So here I can do self.level is equal to 1, and self.experience is equal to -100. And now I just change the code in one place, and it will affect all three of these classes. So over here I can do member.level and member.experience. And if I save and run the program, you can see each character is level 1 and experience is -100. And I can also add another method. So I can add a recover method, and I'll print recovered 10 HP, so 10 health points. And here I'll do self.health is equal to max of 100, or we'll have it be self.health plus 10. And then down here, I can take some health away from a character. So I would do mage.health minus equal 50. So we're subtracting 50 from the mage's health. And if I save and run the program, you can see we reduce the mage's health by 50, whereas the other two, warrior and archer, still have full health. So when you inherit attributes, they are all unique to each instance of a class. Now I'm going to change this. So let's say if a character has health below 60, we would want to recover instead of attacking. So I'll do if member.health is less than 60, member.recover. Else, we would do member.attack. So now let's save and run the program. And you can see warrior attacks, and then the archer recovers 10 HP, and then the archer attacks. So by creating a recover function in the base class, all three of our classes, warrior, mage, and archer, have access to this recover method. And just to show you, I can do warrior.health minus equal 90. Then I save and run the program. You can see warrior has 10 health and we recover 10 HP, and the same for the mage and archer attacks. Okay, so just by modifying the parent class, the child classes all inherit these properties. Now we can actually override these defined methods over here. So earlier we said that warrior would slash with a sword and mage would use a fire spell, so we don't have to punch. So here I'll do attack self, and I'll print slashed with a sword. And let's do the same for magician. Used a fire spell. And finally for archer, shot an arrow. So each of our classes inherit these attributes and these methods, but we can override the methods so that instead of using this attack method, each class now has their own attack method. And they can override the attack method of the base class without affecting the other attributes and methods that they inherit. So these classes will still have access to their health, weapon, level, and experience, and they can also call recover. So let's save and run the program, and you can see the archer shot an arrow, but these other two classes, they just call recover because their health is below 60. So the recover method and these other attributes that we inherit were not affected just because we added an attack method for each class. And over here, where we deduct health from our mage and warrior, I'm just going to remove them. So now, if I save and run the program, you can see warrior slashed with a sword, mage used a fire spell, and the archer shot an arrow. Alright, so that's the basics of inheritance in Python. We have 3 character classes inheriting from this base game character class. And in the next video, I will go over the super function, which is useful for accessing the attributes or methods if we override them in our child classes. So here you can see warrior and mage. We have different attack methods because we override them. However, these 3 classes are still capable of calling this attack method, so attacking with a punch. And we'll go over that in the next video. Alright, so hopefully you found this video helpful, and if you did, make sure you give this video a like. If you have any questions, let me know down below in the comments. And if you want to stay up to date for more Python tutorials like this one, make sure you subscribe to the channel, and I'll see you in the next video. Bye bye.